All right. You have studied this before, but we are going to go into depth. You still went into depth before, but you have probably forgotten some of it because how could you not? And this is one of those rare times when vocabulary becomes important. So that's this first part is going to be vocabulary, but then we're going to actually be doing math. Knowing the vocabulary, though, will help you understand. All right, anyway, here we go. We're going to be talking about polynomials, one of the most loved things in algebra. And without defining anything right now, polynomials is a collection of terms. And terms are separated by plus signs. Very important. Now, what that means is this is a polynomial. But to be very pure about the whole thing, I have to rewrite this because terms are separated only by plus signs. So here I go. I'm going to rewrite this. Oh, and I have a little place down here that says rewrite. Okay. Negative 5c to the sixth plus negative 7c to the third plus 6c squared plus 3c plus negative 5. Doing that mentally helps you separate the terms. All right, so if we were making a list of terms, I would write them here. I even have a special little place here. So let me erase the negative sign there. Negative 5c to the sixth. I woke up at 3 today, just all excited about working with polynomials today and really getting into them and analyzing them. And we're going to do a lot of analyzing of polynomials for the rest of the course, really. We're going to be working on other things too, but polynomials comes into a lot of it. So negative 5c to the sixth is the first term. Negative 7c to the third is the second term. 6c to the second power, which is the third term. And then 3c to the 1 power. And then negative 5. And now I'm going to throw something at you you have not seen before, probably. And here it is. This negative 5 isn't really just sitting there by itself. It has something invisible next to it. So before we go on, I'm going to take you back briefly to those rules of exponents you learned in beginning algebra. And just one of the easier rules that's kind of strange, but that any number raised to the 0 power is 1. So since negative 5, let me write it up here, negative 5 is exactly the same thing as negative 5 times 1. And 1 equals x to the 0 power. It ends up this term is actually negative 5 times x to the 0 power. We don't write it out, but I am going to write it out here because then, except here it'll be c, of course, because The variable we're using is c. This is going to be 5 times z to the 0 power. How does that feel? I bet that feels strange. I thought it was kind of weird when I was a student, learned it for the first time. I think my reaction to just about everything new was, well, you've got to be kidding. Well, no. The teacher was not kidding. So here we are. Here are our 1, 2, 3, 4, 5 terms. All right, now we're going to talk about the different aspects of terms. First, notice that each of the numbers and letters that makes up a term consists of numbers that are multiplied by each other and really like negative 5c to the 6th. Is really negative 5 times c times c times c times c times c times c. That's what negative 5 times c to the 6th is. Notice they're all multiplied by each other. Same thing here, negative 7 c to the 3rd is negative 7 times c times c times c. And 6c squared is what we call it, is c times c. All right, 6c times c. 6 times c times c. And 3 times c. And of course, negative 5 times c to the 0, which is really 1. And a reason we never write it. Okay, so terms consist of, let's jump down to what is a term. Terms consist of numbers and variables. And variables that are multiplied together. Then when the multiplication stops, let me write this here. C times C times C times C times C times C. When the multiplication stops, that's where the plus sign comes in to separate the terms. See, the pluses are the separators, and inside each terms, the numbers and the variables are multiplied together. Yes, they are. That's what a term is, and terms combined together, well, not necessarily combined, that's the wrong word. But terms, collections of terms, how about that? Collections of terms are polynomials, and how each term is connected is with a plus sign. Now, there are parts of terms. The numbers that multiply the variables are called the coefficients, which is Latin for works together. That's why they're called coefficients. They work with the variables. So the coefficient of this term is negative 5. And the coefficient of this term is negative 7. And the coefficient of this term is 6. And the coefficient of this term is 3. And if you're thinking of this term as being -5 times c to the 0, the coefficient is -5. There are debates about whether the number at the end should be included with the coefficients or should be set aside as a constant. We're going to kind of do both. Okay, now, every term has a degree. It's the degree of the variable when you're only using one variable. So the degree of this term is 6. The degree of this term is 3. The degree of this term is 2. The degree of this term is 1. And the degree of this term is 0. All constants have degree 0. Now, the degree of the polynomial. Well, the degree of this polynomial, we don't need all these boxes for that question. The degree of this polynomial is the highest degree, 6. So I'm going to put that, I guess I could put it there, 6. The degree of the polynomial is the highest degree term. That is the degree of the highest degree term, which should be in front. And then notice that the degrees go downhill. 1 and 0. All right, this is called descending order. Very important that you put your polynomials in descending order. So I'm going to write that up here. All of this should be sounding very, very familiar. Okay, now, terms have names. Fred, Sarah, Keisha, Herman. Not like that, no, no. But people have names and terms have names. The name of this term is not exciting. It's the 6th degree term. Since this is the highest degree term and in front of the polynomial, it's also called the leading term. Now, how can I fit all this in there? By making the box really, really big. This is also the leading term. So we'll jump down below here and notice what they're asking is, what is the leading term? Well, the leading term is the highest degree term, which should be in front and therefore leading. -5 c to the 6th. There's only one leading term. Okay, so the name of each term. Let's go back to that. There are the terms. Okay, this term is a third degree term. Let me make this smaller. Because we said the degree of this term, -7 times c to the third, the degree of that term is 3. There's a name for third degree terms. Name of term, it's cubic. This is a cubic term. This is a second degree term, which also has a special name, quadratic. Q-U-A-D-R-A-T-I-C, the quadratic term. This 1 degree term is a linear term. Linear term. And all 0 degree terms are called constants. So you have a leading term, you have a cubic term, quadratic term, linear term, and constant term. And it's all governed by the power, the degree of the term. Now, the leading term, there's only going to be one of those in a polynomial. And when you have a leading term, then the number in front of the variable is the leading coefficient, -5. This ends up being incredibly important, as you will find out. On the other hand, the constant term is over here. We already talked about that. The constant term is -5. And really and truly, you don't bother to write c to the 0. You would just write it like this. Well, I wrote in there. Let me erase it. There. Okay. Now, there are different kinds of individual terms. A monomial would be one term. Like, we could even pick a term from up here. If I were to take -7c to the third, but it was just there all by itself. No, you see, I don't want you getting confused. So I'm going to make up one. How about 13x to the 5th power? I just made that up. It's not plus anything, or it doesn't have a plus in front of it where it's being added on to other terms. It's just there by itself. This is a little bitty 5th degree term. Well, it's not so little, but it's one term, a monomial. A binomial is something like 6x x to the 7th power plus 4x squared. Or I don't want you to think it's just even numbers, so I'm going to get rid of that 4 and make it a 3 or a 5. How about that? That's a binomial. We're going to be doing lots with binomials. A trinomial is something you're really going to be dealing with next week a lot. Numbers like 3x squared plus 2x plus 1. Minus 1. Let's make it minus 1. Minus 1? Yeah. How about that? There are 3 terms there. 1, 2, 3. Try. What are the 3 terms? You've got 3x squared. You've got 2x, and you've got negative 1. Because plus signs separate the terms. Okay, let's look at an example of a constant polynomial. How about 3? Any number. Or 4/5. A constant polynomial is just a number. Of course, you could say, well, it's like x to the 0. Or d to the 0. And yeah, you'd be true. What you would be saying would be true. But a constant polynomial is just a constant. An example of a linear polynomial is there. 3x plus 1. Linear because the variable is to the 1 power. Well, that means this whole little polynomial is to the 1 power. It's linear. It's a linear term and a linear polynomial. An example of a quadratic trinomial, well, here was one of them. 3x squared plus 2x minus 1. And I don't know, how about x squared minus 2x minus 3. Not terribly creative. That's a quadratic trinomial, but what about a quadratic binomial? How about x squared minus 4? And a cubic polynomial. You're going to get to know those really well. X to the 3rd minus 4x squared plus 2x minus 5. That's an x. That's a cubic polynomial. Of course, I could also make a shorter one. How about x to the 3rd plus 27? In fact, if the truth be told, I could make a cubic monomial to x to the 3rd. That's another example. After all, a monomial is a polynomial. It's a type of a polynomial that's really short. And a quartic. You're going to be working with those the second half of the semester. What is a quartic? Highest power 4. Negative 5x, I'm just making this up. Negative 5x to the 4th minus 7x to the 3rd plus 3x squared minus 2x plus 1. That would be a typical quartic polynomial. Of course, you could have a quartic monomial, a quartic binomial, a quartic trinomial. But that's just what I decided to make up. Notice you have a 4th degree term, a 3rd degree term, a 2nd degree term, a 1st degree term, and a 0 degree term. Okay. Any discussion or questions about this? As you can see, this just takes a certain amount of memorizing. I'm not going to ask you to fill in a chart like this on a test. I just want you to know this so that what we're about to do will make sense, because this is the type of thing you could see on the next test. But you already know how to do that. You know how to add polynomials by combining like terms. That's what we're going to do now. We're going to add them, polynomials. We're going to subtract polynomials. We're going to multiply polynomials, but we aren't going to divide them yet. You'll be glad to know. Okay. So, how do you add them? Well, like this. This is 2b squared plus 10f squared plus 13 plus 10b squared minus 5f squared minus 5. Oh my goodness. Okay. The b squared terms are like terms. The f squared terms are like terms. And the constants are like terms. If you want to, you can write like terms together, which makes it kind of easier. 2b squared plus 10b squared plus 10f squared minus 5f squared plus 13 minus 5. Now watch what I do. I'm going to do the following. And I'm not telling you to do this. I'm just saying you can do it mentally if it helps. The way that you add like terms together or subtract like terms, add or subtract, is you keep the variable with its power just the way it is, you do not multiply the variables. You just write it down. And I'm going to add the numbers in the parentheses. And over here, I'm going to take the 10 and subtract the 5. And over here, well, that doesn't need to be complicated. 13 minus 5 is 8. Now over here, 2 plus 10 is 12. So this is 12b squared. And 10 minus 5 is 5. So this is 5f squared. And then plus 8. Here would be your answer. Here is your answer that you would write in the answer box in my math lab. All of these are homework questions in my math lab. That can be hard for people to remember sometime. When they're adding, they want to take an extra step and add the variables, or take an extra step and multiply the variables, but you don't do it. The variables stay the same, and it's the numbers you add or subtract. Now comes subtraction, which is dangerous because it looks so easy. Here you've got polynomial number 1, and you're subtracting polynomial number 2. What could be easier? Well, with polynomials, it's deceptively dangerous. First, the first polynomial stays just the way it is. Negative 13 c squared plus 4c plus 6. The minus sign in front of parentheses means that you distribute the minus sign to all the terms in the parentheses. So that you're going to have minus 6c squared. And then minus times plus 7c is minus 7c. And minus times minus 3, because these really are minuses, but you can think of them as being negatives too. Negative times negative 3 is positive 3. But you're dealing with addition and subtraction, so a minus times a minus gives you a plus 3. Without these parentheses and distributing the minus sign, just like you would a negative 1, you would have a bunch of sign errors in there and you would not get the right answer. So now I have to look here. My c squared terms are like terms. My c terms, c to the 1 power, are like terms. And my constant terms are like terms. So I'm going to have negative 13 c squared minus 6c squared plus 4c minus 7c plus 6 plus 3, because we had negative times negative is positive. So positive 6 plus 3. Okay, and now just to be consistent and keep using the same method, this would be negative 13 minus 6. This would be 4 minus 7. And this would be just 6 plus 3 is 9. So the challenge is with adding and subtracting variable terms. For instance, this is negative 13, duh, you can tell that. But really and truly, this is negative 13 plus negative 6, c squared. If you think of it that way, then you're just going to add 13 and 6. That's 19, and both of them are negative. So the answer is negative. All right, now, 4 minus 7 is negative 3. And then plus 9. Okay, here, before you put an answer into MyMathLab, you have to turn this back into the way we write signs that are together. This is plus minus, which is minus. So you're going to have negative 19c squared minus 3c plus 9. And that's your answer. Polynomial subtraction can be very dangerous. The first polynomial stays the same, but the second polynomial is multiplied by that negative in front of the parentheses, which is the same thing as a negative 1. Stop me if you want to say something or ask a question. For some of you, this is so old, but for other people, you might not have seen it in a while. Okay, I'm going to go on till I hear something. Oh, let's subtract again, because notice this. You have r squared, you have f squared, and you have rf. You have 3 kinds of terms here. 3 types, 3 kinds. I like that better. 3 kinds of terms. You have r squared terms. You have f squared terms. And you have rf terms. How very strange. But we're going to treat them just as though they were X, Y, and Z, which would be, you know, easier to do. First thing, I'm going to subtract 5r squared plus 6rf minus 4f squared. Now, minus 9r squared. Minus times minus is plus 4rf. And minus times plus is minus 17f squared. So now I don't start combining like terms until now, when all the parentheses are gone. And I can't just make them disappear. Not when I'm subtracting. Up here, when we added, yeah. This is the same thing as if I have an invisible 1 in front of both sets of parentheses. Anytime you multiply by 1, you just get back what you started with. But when you're subtracting, it's a whole different deal. You have to be very careful. All right, I'm going to combine my r squared terms. I'm going to combine my RF terms, since that's the order they have this going in. And I'm going to combine my f squared terms. Okay. Now, five minus 9, r squared, plus 6 plus 4, rf. I'm going to put a plus here. Minus 4 minus 17, f squared. Which looks really scary. So if I were you, I would at least mentally stick a little bitty plus sign in there. This is negative 4 plus negative 17. And in fact, this is 5 plus negative 9. Remember, those invisible plus signs are separating all the terms. Okay, so 5 plus negative 9, or 5 minus 9, is negative 4. And 6 plus 4 is 10. 10 are F. Okay, I can leave this here temporarily. Plus, all right, negative 4 plus negative 17 is negative 21 F squared. And then plus a negative is like plus times negative, which is negative. So the normal everyday way to write this, if anything about math is normal and everyday, there's your answer right there. Negative 4r squared plus 10rf minus 21f squared. R squared. Oh, R squared, that should have been an F. I need people to yell at me. Nicely, but yell at me nonetheless. Ah, it's kind of pretty. Okay, now we get to multiplying. This is a monomial. And this is a binomial. As you're going to see, if you don't already know it, or you might know it but not think of putting it into words, all polynomial multiplication ultimately comes down to multiplying a monomial times a binomial. So here we go. Try to be real fancy here. Here's the way you distribute, which is what you're going to do, although I should have done that in blue. Trying to color code is a wonderful idea, but in execution, it's really hard. Okay, here's what I'm going to do. Here's what you're going to do. Take the seconds, well, take the parentheses, what's in the parentheses, and take this 4z. Sure, you're saying, no, you take it. And multiply by the 3. And multiply by the x. Like that. And then clean it up. This now is a term. And this is a term. All the variables and constants and coefficients, all the numbers and letters in a term are being multiplied. So that means I have 4 times z times 3. I multiply the 4 times the 3. That'll be 12. So I'll have 12z. And if I want to, I can keep the plus sign there for a minute. I have minus x times 4 times z. Well, we always pull the number out to the front. Negatives definitely go in the front. Negative, then move the 4 on out, and then try to write the variables in alphabetical order. Obviously, that's not an absolute requirement because our F was definitely not in alphabetical order. So it's not a strict rule, but it's something that you kind of try to do when you can. So this would be your answer, except of course we combine the plus and the minus. So ultimately it will just be a minus and your answer will be 12 z minus 4xz. And this is a form of multiplication called distribution. Put my little blue box around there. Remember, just yell out if you want to ask anything, or comment, or discuss. Well, I want to discuss terms. Okay. Good for you. Here's the little bugger that gives us all fits. A binomial times a binomial. Are we going to FOIL or are we going to distribute? Oh dear. Well, it ends up whether you FOIL or whether you distribute, it's the same exact thing. It's just more fun to FOIL. But we're not here to have fun, ladies and gentlemen and people. So, we're going to distribute because that's the new way. Somebody decided, and rightly, it's true. There's only one time you can use FOIL, and it's now. When you have a binomial times a binomial, and you can never use FOIL for anything else. So somebody finally said, why make people learn FOIL and learn distribution for everything else? And it's right. I hate to admit it, because I really like FOIL. Okay, so I am going to go back to color coding for doing this. Well, first, always write big. We're going to have 5w minus 4, and remember that's really plus negative 4. And 6w plus 6, and we are going to distribute. Here is exactly how you do it. Take the first term in the first set of parentheses and multiply by the second set of parentheses. Then take the second term from the first set of parentheses and multiply by the second set of parentheses. Cool beans. Now, we're going to do monomial multiplication. That's a monomial. This is a binomial. This is a monomial. That's a binomial. So I'm going to have, oh, this is so cute, 5w times 6w plus 6 times 5w. Plus. negative 4 times 6w plus 6 times negative 4. Well, I didn't have to do those both. There. That is just so incredible. Now, if you did this by foiling, you would discover that the numbers you have now are the FOIL. So you could be cool and tell anybody you want that you foiled. Because you did. But officially what we're doing is distribution. Now, I have had it with color coding. I'm going back to black. 5 times 6 is 30. And W times W is W squared. Plus 6 times 5 is 30, or 6 times 5 times W is 30W. Plus minus 24 W minus 24. Now look. These, and this often happens, we're going to have 30W minus 24W. Now I can do the whole little parentheses thing if I want to. Let's do it. Let's do it. Okay. Boom, boom. We're going to have 30 minus 24 with the W pulled to the end there. And then the minus 24 over here. So 30 minus 24 is positive 6. So I will have 30W squared plus 6W minus 24. Isn't that pretty? Okay, I haven't heard anything, so I'll move on. What about this? The most common things that students want to do, that's an equal sign, wrong. The wrong thing, but it makes sense, is they want the answer to be a squared minus 16f squared. And they're done. And I would love it if it were that easy. But it's not. It's not. It's not. This is a binomial. Now let's look at when you could do that. I'm not saying it's always wrong. I'm not saying that at all. If the problem looked like this. Then you would probably change it to 4af squared. And then, since everything is multiplied inside, this is a monomial now, that you would have 4 squared, a squared, f squared, and your answer would be 16, a squared, f squared, and that would be entirely correct. You have just taken this monomial and you've squared it. But this is not a monomial. It's a binomial. So you can't do that. Instead, you have to do the following. And now we're going to do what we did back here, which is what you do when you multiply. Well, yeah, when you square a binomial, you multiply the binomial times itself. So we're going to take this A. Should I color code? Yeah. We're almost done. Okay, and so this is going to equal A times A minus 4F minus 4F or plus a negative 4F, which might be better here, I don't know. So this is how you would multiply A minus 4F times A minus 4F. You would do it like that. After a while, you get so good at it, you do it in your head. Okay, A times A is A squared. A times minus 4F is minus 4AF. And over here, minus 4F times A is also minus 4AF. And minus 4F times minus 4F is plus 16F squared. Now notice that you have an AF term and an AF term. And remember that you have invisible plus signs. Now that's actually important here because you're going to have A squared plus negative 4 plus negative 4 plus 16 F squared. And I'm forgetting all over the place to put the equal signs. Okay, so we'll have A squared plus negative 4 is negative 8. Okay, now in the time remaining, It is not unusual to be presented with a problem like this.
Can you go back up really quick, please?
Sure. Here or higher?
Yeah, was that the last one?
Yeah.
Okay. All right. Thank you.
Is that all?
Yeah, I was just wanting to look because I didn't finish writing it, but I got it. Thank you.
Okay, great. I'll move this down farther. There. This is a binomial times a trinomial. Here's how you do this. Okay. I'm going to take the 3x and multiply it by the second set of parentheses. And then I'm going to take the plus 2 and multiply it by the second set of parentheses. Now we're down to a monomial times a trinomial. It always works its way down that way. Okay, so we're going to have 3x times 5x squared. Okay, plus 3x times 3x plus negative 5. That's what I should have done. I should have put the plus in there. Good. All right, plus negative 5 times 3x times 3x. So 3x gets multiplied by 5x squared plus 3x and plus negative 5. Gets multiplied by all three of those terms. Now the plus 2 is going to get multiplied by each of these terms. Plus 2 times 5x squared plus 2, well, it's times plus 3x, but it's positive 3x, plus 2 times negative 5. Okay. Now, 3 times 5 is 15. X to the 1 times x to the 2 is x to the 3. And here's a rule that you've learned but long ago. X to the 1 times x to the 2 equals x to the 1 plus 2, which is x to the 3. Plus 3 times 3 is 9. X to the 1 times x to the 1 equals x to the 1 plus 1, which is x to the 2. Plus negative 15x. Wonder if I should leave that way. Okay, and plus 10x squared plus 6x plus negative 10. And so finally, 15x to the 3rd. Now we just combine our like terms. Plus 9x squared plus 10x squared plus negative 15x plus 6x plus negative 10, which is minus 10. So that we have 15x to the 3rd. Oh, that's a square. Here you go. Plus 9 plus 10 x squared plus negative 15 plus 6 x minus 10. Now we're almost done. Yay! 15 x to the 3rd plus 19 x squared. All right, plus negative 15 plus 6 is negative 9. X minus 10, and then finally 15x to the 3rd plus 19x squared minus 9x minus 10. It's the same mechanics, the distribution method. We're going to be doing this tomorrow as well, but we're going to make it fancier. So just let me give you a preview. Tomorrow we're going to say that f of x equals 3x plus 2, and g of x equals 5x squared plus 3x minus 5. And you're going to be asked to do this. And what that means is you're going to multiply f of x times g of x, which of course is what we just did. We just multiplied 3x plus 2 times 5x squared plus 3x minus 5. And actually this would probably not have the dot, it would just be fg in parentheses of x, which means to take f of x and multiply it by g of x. This is part of function arithmetic. So tomorrow we're going to be adding functions, subtracting functions, multiplying functions, dividing functions. We're going to be doing something new to you, perhaps. I think we did it a little bit earlier. Maybe not. Maybe not. We're going to be composing, which is also called composition of functions. And we're going to be finding inverses of functions. So we're going to be doing what we did today, but we're going to be doing it with function notation. There you go, function notation. So it's going to be an interesting day tomorrow, so make sure you understand this old stuff, and you can do it. Talk to you later. Hang around if you have questions. That's it for today.